All right, so now we can move on. If I swap row 2 with row 3, I can be left with, I'll be left with our fifth operation, swap row 2 with row 3. And I think I can probably do two operations at once here. If I then subtract 4/9 times row 2, the now row 2, the new row 2, from row 3. Okay, so keep in mind that we're now, so this is now row 1, this is now row 3, and this is now row 2. Okay, so I can rewrite this now. So if I'm subtracting 4/9 times row 2, and this third row is now row 2 from row 3, then this second row here is now row 3. The first row doesn't change. I'll be left with -5, 3, 4, and then 2. And then here's the tricky part. The third row now becomes the second row, so we're left with 0, 9, 7, and sorry about that. 0, 9, 7, and 6. That was just the uploading that was going on from a previous video that I made. So we have 0, 9, 7, and 6. And then if we now subtract 4/9 times that row from row 3, we'll now eliminate this 4 that was here. And then we'll be left with 35/9 and 70/3. Okay. So a little bit messy. Did not say that this was going to be an easy problem from the start. So let's keep moving through this because it seems like we're almost getting there. I think what we can do now, so the 35 and the 70 are multiples of each other, and then the 9 and the 3 are as well. So if I multiply the third row by 9/35, that would create a 1 here, which is what I want. Our identity matrix has a 1 in this position. So, and then also, it would reduce this 70, which is exactly what we want. And it would also reduce the 3. Oh. Okay, so maybe we can add in one more step here, if that's not too much. We multiply row 3 by 9/35. Okay, so if we do that, this now becomes happen again. This now becomes, and I'm going to grab a different color. This becomes a 1, which is exactly what we want. And then this one becomes a 6, I believe. Yes, 6. Okay, so Now we're getting really close, where our third row is actually completed, which is perfect. We have a value for z equals 6. So all we have to do is eliminate some things in this first row and the second row, and we should be okay. So moving down, if we take, now this is a perfect opportunity to use this third row to eliminate some things from the third column in the first two rows. So if I multiply the third row by 7 and subtract that from row 2, I can eliminate that 7, which is perfect. We can do that. So if we use that to our advantage, we can then multiply this third row by a value that can eliminate numbers in the third column from the first two rows. So from the second row, we can actually eliminate that 7 by subtracting 7 times row 3 from row 2. So we'll make that our 8th step here. So we can take, so our 8th step will be subtract 7 times row 3 from row 2. And then that's going to eliminate this 7 and then turn this 6 into a negative 36, right? Because it's 42 and then 42 taken away from 6 becomes a negative 36. And then to make this 9 into a 1, we can actually divide the whole row by 9. Which is convenient because 9 actually goes into 36. So let's take row 2, divide row 2 by 9. Okay, so if we do that, we'll be left with the same thing in the first row, negative 5, 3, 4, and 2. And then we'll be left with 0, 1, 0, and then negative 36 divided by 9 is negative 4. And then 0, 0, 1, 6 in the third row. Okay. So we're almost there. I can see it. We're really, really close. I think the next thing that we can do is eliminate this 4 here by multiplying the third row by 4 and subtracting that from row 1. So our 9th step, or sorry, our 10th step. Oof, I'm really moving along here. Our 10th step is going to be to subtract 4 times row 3 from row 1. Okay. And if we do that, I'm realizing now that that is probably not the best thing that we should do first. If I realize that the issue with, you can do it. If we subtract 4 times row 3 from row 1, we could actually do it. Let's do it this way. Now let's see what happens. If we do that, this is what we'll be left with. Subtract 4 times row 3 from row 1. Well, we're just going to be left with -5 again. And then 0 again. So we'll be left with 3 here. And then 4 times row 3 here from row 1. And then that is going to eliminate that and give us a 0. And then 4 times row 3, which is 24. And then from row 1, which is going to give us -22. Okay? And then we're left with 0, 1, 0, -4. And 0, 0, 1, 6. Okay, now we can eliminate the 3 because we want a 1 to be where this -5 is, and we want a 0 where this 3 is to get our identity matrix. So to eliminate that 3, we can just multiply our second row by 3 and subtract that from row 1. So, and then the other option would be to multiply the second row by -3 and add that to row 1. So add -3, add -3 times row 2 to row 1. And then this will eliminate the 3 in the second column of the first row. So if we rewrite this, we'll be left with -5, 0, 0, and then -3 times row 2, which is so -3 times -4 is 12, and then plus -22 is -10. And then we're just left with 0, 1, 0, -4, 0, 0, 1, 6. And we're pretty much there. One more step, and then we're going to have our identity matrix and all of our solutions. All we need to do is divide our row 1 by -5. So if we, our 12th step, 12th and final step, divide row 1 by -5. So when we do that, you'll see that the -5 then becomes a 1. Then we're left with 0, 0. And then -10 divided by -5 is 2. And we're left with 0, 1, 0, -4, 0, 0, 1, 6. And there we are. We have our identity matrix. We have all of our solutions after 12 steps. We're finally given that x is equal to 2, y is equal to -4, and z is equal to 6. So another way of writing this would be 2, -4, 6. And after that long, long solution, we have finally arrived.